Vera Rubin is an American astrologer who is famous for her work on galaxy rotation rates. She has been with the Carnegie Institution of Washington since 1965, with more than half of a century of astronomer experience. She is a recipient of countless scientific prizes and recognition. Rubin has also encouraged lowering of the egregious barriers which once excluded women from graduate programs and observatories, and actively discouraging them from entering the field. She was the first woman granted the privilege to use the 200-inch Hale telescope at Palomar Observatory. Her most famous discovery was her calculations of the leftover motions of the universe after subtracting the known expansion of the universe, which birthed the hypothetical existence of dark matter. Through this study of galaxy dynamics, an understanding of large-scale structure and bulk motions of the universe was revealed. In 1960, before the research on dark matter, Rubin focused on quasars, which are distant and energetic points of light discovered. Working in a team with Kent Ford, he perfected a new electronic instrument called the spectrograph that made it easier to record the data needed to measure the rotation of a galaxy. She worked on detecting a large-scale motion of 109 galaxies through use of this device. This was named the Rubin-Ford effect, based almost completely on the arsenal of data that she created. The team compiled a set of the spectra of spiral galaxies, each one revealing the speed of hydrogen gas, and starts around the galaxy's center. This was a result of the Doppler effect, unexpected to astronomers who had predicted to see the most distant stars move slowly. The prediction was based on how outer planets in our solar system orbit the Sun at a snail's pace when compared to the inner planets. Nearly all of Rubin's spectra were flat because stars move at a constant speed, out to the edges of the galaxy. Both quasars and the motion of the galaxy seemed too competitive and controversial for Rubin, so she changed focus. Later on in her life, when Rubin was an assistant professor at Georgetown University, she taught a class in statistical astronomy. She created a problem for the class to deduce the rotational properties of the outer regions from a catalog of stellar motions, a new question to avoid conflict with the work of other astronomers. At the time, stellar motions near the center of galaxies was a prominent field of study. When it became clear that the data available to answer this question was not available, she was welcome to use the technology available at Kitt Peak National Observatory and at Palomar. Her only goal was to find distant stars in the plane of the Milky Way and determine their velocities. She explained, "I wanted to know how galaxies ended, which is not a question anyone ever talked about." Rubin and Ford's previous examination of the wispy outer reaches served as a jumping-off point for Rubin's career. Rubin saw that a lot of extra matter, unable to be detected by her instruments, had to be somewhere in order to keep the stars from flying out of the galaxy. This resulted in the discovery that a lot of unseen matter enshrouded the entire visible disks of galaxies and added enough mass to accelerate the outermost stars. Rubin's conclusions pioneered studies that focus on how galaxies revolve within massive shrouds of dark matter. Every astronomy text references, includes, or is based off of her evidence. Because of her discoveries, dark matter is one of the most active concerns in astronomy. She continues to methodically analyze how stars move in the outskirts of galaxies. In the present time, Rubin, now 73, can see that her discoveries influence further knowledge regarding the nature of galaxies. Half a mile beneath the surface of the Earth, within a cavern of iron ore in Minnesota, special detectors cooled to absolute zero are recording data. Their goal is that underground and away from disruptive cosmic rays, one of these exotic particles will occasionally bump into a detector and release a signal. This project, called the Cryogenic Dark Matter Search, is one of many projects around the world attempting to discover a type of matter that is only hypothetically proven. New particle theories in physics, far beyond the standard model, suggest that dark matter could exist all around us. There are a more modern theory, one which is possible because of sophisticated measurements of the cosmic microwave background, which is the name of the remnant radiation left over from the Big Bang. This theory tells us that there is 6 times as much dark matter in the universe as there is of ordinary elements that make up stars, nebulae, and everything on Earth.